All right, greetings everybody. This is Guy Reams from Physical Security University. You can now hear me, so I will repeat myself over again. Hopefully I have audio now. Kiko, do I have audio now?
Yes, hi, you do.
Okay, great. All right, so welcome everybody. Thank you for joining our session. I had myself on mute and didn't realize it. Welcome to Physical Security University. This class is going to be the PSU-301 course, which is implementing IP surveillance cameras in a remote or mobile environment. We're going to have a lot of fun today going over some content, but also taking a look at some products and showing you some sample deployment scenarios. During this session, I have Kiko with us today. She is from the Ingram Micro Physical Security Business Unit, and she is stepping in to help moderate this training meeting. She will be assisting by answering chat questions. So if you have any comments or questions or need assistance during the call, then please feel free to provide that in the chat window. And if I see the question while I'm talking, I will address it. But if I miss it, Kiko will bring it to my attention. Well, welcome everybody. Today's session is going to be basically in two parts. We're going to go over some content, and then after the content, we're going to take a look at some deployment scenarios that are common for wireless camera devices and also wireless bridge scenarios. So you're going to see both of those today. I'm also going to introduce you to how to get access to this content after the class is done. And I'm also going to introduce you to how to get access to more exciting content coming from Physical Security University. Unless there's anything else, I'm going to go ahead and get started. Like I said before, if you're just joining, feel free to use the chat window to ask questions as we progress. And we're going to go ahead and get started then. All right, you should see my my screen ahead of you, in front of you, hopefully. And we are going to go ahead and get started by talking about IP cameras in a mobile environment. After we are done with this session, I will take 10 or 15 minutes to show you how to get access to Physical Security University and how to get access to this content after this webinar is over. And for those of you who may be curious, this content is being recorded and will be published on Physical Security University once we are done. All right, well, let's go ahead and get started. Before we get started, I just want to make sure I make note of a couple of issues. First, this course is being brought to you by TrendNet and Ingenious. For this particular course, Ingenious has provided us with some wireless bridge products and wireless access points, and I will show you those in a minute. And they are set up behind me, and we're going to be using those for our deployment scenarios. TrendNet has been gracious enough to provide us with a couple of cameras that we can do our demonstrations with, and they've also helped sponsor this course, and they are also set up behind me, and we'll be taking a look at those in a minute as well. Let's go ahead and I'll just review briefly what we are going to be covering. So first off, we're going to talk about reasons for using wireless for IP surveillance and reasons why not to use wireless. In fact, I think probably there's a bigger emphasis on not to use it. I know this is a class about getting you to put cameras up on a wireless type of scenario, but it's very important to understand when it's a good idea and when it's a bad idea. And I'm going to talk a little bit about that. And secondly, the use of mobile broadband wireless networks. I get a lot of questions about this from customers, and also I tried it several times when I was an integrator myself, and I learned that there are some situations where mobile broadband would work for IP surveillance, but they're very limited, and I'll talk about the scope of that when we get there. I want to also talk about if you ever do get into a situation where you're deploying cameras in a wireless or mobile environment, when would be a good idea for you to bring in outside expertise? So I just want to help you learn from my past mistakes of when it's a bad idea to try to do it yourself. And I'll talk about when it's bad and when it's good. Finally, I'll take a brief dive into wireless LAN technologies. We don't have a lot of time to break into all the different details, but I'll talk about some of the concepts, terminologies, and some of the wireless LAN stuff that you need to know. Finally, we'll have a primer on wireless security. I'll talk about the different wireless security standards, and we'll apply that to the camera devices and to the wireless access points and bridges that I will show you today. Finally, at the end, we are going to spend time working with the products behind me, and I'll show you the products. So if you look in the video thing in the WebEx, you'll see the products that I've set behind me. I have a variety of ingenious wireless access point products and wireless bridge products. I also have some TrendNet cameras, and we are going to take a few minutes and do some deployment scenarios, and I'm going to show you how I set these up and what I did to do that, and talk about the issues that you will face if you ever try to do this yourself, whether it's in a small home environment, a small retail environment, or whether it's in a larger enterprise environment. Okay, so let's go ahead and get started. Okay, so first off, wireless LAN technologies. Let's talk about when you should use it and when you should not use it. And we might get into some pretty technical discussions here, so if you do have any questions or something I say is confusing, then please feel free to chat away and I'll respond accordingly. So when I say wireless LAN technologies, I'm not referring to cellular, CDMA, or 3G or 4G technologies. I'm referring to 802.11 standard. So I'm referring to wireless LAN, which the IEEE is defined with the number 802.11. So let me get this off. Let me just say this right away. If you're curious that maybe wireless is cheaper to install than wired cameras, let me just save you the evaluation. It's not. It just simply is not cheaper in grand total to implement all cameras with IP surveillance. Now, if you get to a customer and that customer has maybe one camera, like they want to put one or two cameras in, then maybe we could get into a scenario where the cameras might be cheaper to install with wireless. But there are a lot of reasons why wireless can get expensive, and we'll talk about some of those reasons here in a minute. But more importantly, you should always go into it with the assumption that if I'm putting in an IP camera in a customer's environment, my first goal should be put it in with an unshielded twisted pair copper cabling first. That should be your first goal. If that doesn't work for whatever reason, then wireless cameras are certainly an attractive option. So when is it best to use wireless? Well, it's best to use it when copper cabling just cannot reach. Either because copper cabling is too long, although that's not a reason alone, because we do have the ability to extend copper now, in some cases up to 600 feet without any significant attenuation, using long-range Ethernet or using devices that will actually extend Ethernet. But where copper it's too great of a distance for copper, or where you just simply can't get copper. And one of those cases may be you're trying to run copper up into a crawl space or an attic or up onto a roof or across somebody else's property or across a parking lot or over an awning or something where installing copper cabling is too difficult. In addition, sometimes when you're running copper cabling, customers will want their cameras on the outside of their building, like they're trying to reduce theft or protect employees or protect assets, and they'll want a camera on the outside of the building, or maybe monitoring the front door or something like that. Well, if you want to do that, then to run a copper cabling through the interior of the building, if you can poke a hole through the wall and get right to where the camera is, that's great. But if you have to have the copper cabling leave the building and then traverse for a distance and then get to the camera, now you're dealing with a problem, because now you have to deal with the fact that you have to have a strategy for handling the handoff from the copper from inside to outside. It's not a good idea to just deploy copper on an outside of a building without some isolation of potential lightning strike or power surge or something along those lines. So you must protect copper cabling when it comes into the building with something. The best way to do it is with a building entrance terminal, but sometimes we can't do that, or there's a scenario where it's just impossible, or it's too expensive, and in that case, wireless can be a great alternative. The other thing you may want to use is fiber optics to get to a cable. Well, fiber can get very expensive, especially when we don't have pathway for the fiber, or when we have to trench streets or rip up concrete or across somebody else's property. So keep in mind, fiber can be an alternative. Where fiber works and wireless doesn't is when you have a deployment of mini cameras at another location. So let's say you're running a fiber connection from one part of a building to another, maybe back to a warehouse, and you're going to put 15 or 20 cameras back there. Well, now fiber looks like a real attractive option because now you're adding multiple cameras. But if you're just trying to reach one or two cameras, then wireless is significantly more attractive than fiber. Wireless technologies are used to reach difficult locations. But keep in mind, you must have AC power available somewhere to get to that camera. Now, AC power can come in two shapes and forms. First, you can have an AC power source right at the camera. So if the camera accepts an AC power input, you can simply plug the camera into that power source and you're happy, and then the camera is wireless. Or if the camera is not wireless and the camera needs a bridge, which I will show you how that works in a minute, then you must power the bridge and the camera. So you have to have an AC power source close by in order for wireless to work. Now, that's not always true because the other form it can take is maybe AC power is nearby but not real close. And so what I mean by that is maybe it's 100 feet away. So the AC power source is 100 feet away. Well, you could actually install a AC to DC power converter and then run DC power from that converter to your camera device and power it that way. However, you're going to find most wireless cameras don't accept that type of input, unfortunately. However, there are PoE injectors and or wireless bridges that do accept DC power. So you could potentially install a power supply, a DC power supply at an AC power source, and then run copper cabling to your location and power either your bridge and or your camera in that mechanism. But keep in mind, wherever you deploy wireless, you have to have a power source. Okay? And now let's just, and you saw one of my pictures come up there, one of the things that I always get from people is, and I've been on lots of job walks, and they'll always say, well, hey, guy, what about that power pole over there? Can I install my camera there? And I'm like, well, no, because we need power. And they're like, well, the power pole has power. Well, you can't just go stealing from the power company power, right? You can't just tap in somewhere. And secondly, normally power on power poles is a lot higher voltage, even if it's an internal power pole. So let's say it's a company-owned power pole. Even then, the voltage is probably too high and probably not in the right format that could be actually stepped down to the type of power that your camera or bridge would accept. Also, people will look at light poles and they'll go, hey, guy, there's a light pole over there. That's a perfect place for my camera. Well, it may be perfect place for the camera. However, you still need power. And light poles don't oftentimes provide the correct power. Usually the voltage is too high. And even if the voltage is good, oftentimes light poles are on timers because we turn the timers off at night or at different times because or during the day because the light poles are too expensive to run all the time. So consequently, if the light pole does not have the capacity to hand off power to a 110 or 120 volt power supply, then you cannot use the light pole. So this is something to keep in mind. Don't just say yes to a customer when they say light pole. you need to say, well, wait a minute. We got to check to see, is the power consistent, and does the power come out in the right voltage? Sometimes you'll get light poles that will have a step-down transformer on them. Those are great. And sometimes you'll get light poles with a little device at the top that will cut the light pole off during the day, but it also has a 110 adapter on it. These are more expensive light poles, but sometimes you'll get a city that will do them. But don't think you can just go use a city's light pole without their permission. And I've never heard of a city giving a customer permission to use their light pole, unless you're fortuitous enough to actually have the city as a client. So, but normally you're not going to want to use one of those poles, and so you'll be using private poles. In addition, keep in mind that even if you find a private pole that has the proper power source and is not turned off by a timer, then your other challenge is you now got to put a bridge product up there and a camera product up there and potentially a light source. If you put all those things up there, you got to be very careful, because now the pole is dealing with the weight, where you may bend the pole or cause other issues with the accessories on that pole. So be very careful when customers recommend poles. It's not always the best case. However, as long as you have a power source, you can find some very interesting and attractive places to put cameras that you could otherwise not reach. Okay? Next thing, when implementing wireless, you must recognize that 802.11 is a public wireless spectrum. Now, I know all of you knew that already, but when I mean public, I mean it is free. It is license free. That means I could decide right now to take my extremely powerful ingenious access point back here, turn on the power on those antennas to their max rating, and aim it at my neighbor and take down their wireless, right? There's nothing stopping me from doing that. It's a free country. It's license free, right? So, and the same thing goes. Somebody can decide to install some microwave dish that competes with the wireless signal that you're using, and boom, your camera no longer works. So be very mindful when you decide to go after a deployment of many cameras in wireless, especially outdoors, and even in indoors, especially in a multi-resident facility or in a building that has shared tenant access. Be careful, because access points spring up like crazy. Just this morning when I was setting up this Ingenious box, by the way, this Ingenious one you're seeing right here, the ENH500, has a nice little discovery tool where you can discover, do a little site survey. And I did a little site survey on it, and I counted no less than 22 access points right here in my building. So I'm in a shared tenant space, and I got access points all over the place. And so you either got to overpower your neighbors, or you've got to deal with a spectrum that they're not on, and sometimes that can get difficult. And so, and be mindful that once you put it in, there's no guarantee that it's going to continue to work, because wireless is unpredictable. My final point is important, and you saw an image there a few minutes ago. My final point is important, and that is, just because the customer has some SOHO wireless product, like a Linksys or whatever, they have a little wireless product in their office, doesn't mean you can just throw a camera on it and it's going to work great. So implementing wireless cameras is a lot different than implementing wireless PCs and laptops. PCs and laptops tend to burst their signal a lot, and so what can be handled in 1 second will pretty much be dead time from then on. So the wireless devices don't have to be that consistent. But in camera scenarios, you need a consistent, steady throughput with a consistent, steady stream in order to accommodate the camera, especially if you're doing recording. So consequently, do not consider the fact that they have wires they can just throw up a camera. Now, I'll check that with, maybe they're just putting in one small, low-resolution camera, and they just want to reach one little location and they want to use their current wireless. That may work. I'm not saying it won't completely work. But chances are, if you're deploying one or more cameras and you want a consistent, steady stream from that camera, be mindful that you don't just try to piggyback off an existing wireless. You most likely are going to need to put in wireless. Now, in addition, the wireless will most likely also require more access points or a greater antenna gain than what you're normally used to in a small wireless product. So they don't make all wireless access points the same, and they don't make all wireless bridges the same. Consequently, make sure that you look at the right products and make sure that you have the correct wireless implementation to handle the type of stream that you're going to get from a camera. All right, there you go. So this is why you should and should not use wireless LAN technologies for IP surveillance. All right, I get this question a lot, and I'll give you a little history lesson, or in my personal background. I've been chasing this very large, I'll just say, utility company for years. I've been trying to get in there to do some work for them. And finally, I got the opportunity to bid on a project. And the project basically was through their marketing department. And their marketing department wanted to do time-lapse footage with a security camera, but they wanted to use a mobile network. And not only did they want to use a mobile network, but they wanted to use it over a 3G connection. And they wanted it to be out completely in the middle of nowhere. Well, the problem is there was no cell phone towers around. So me being the engineer that I was, I thought, you know what, I know what I'm going to do. I'm going to hook up my little 3G router, similar to this TrendNet one you see here pictured. I'm going to hook up this 3G router, connect it to a provider, let's say Verizon. So basically on these routers, you can hook your USB modem that you buy from Verizon right to the back of it. And on the back of that USB modem, in this case it was Verizon, there was a little antenna connector. So I ran a little antenna connector off there, and I connected it to this really powerful Yagi antenna, but I aimed at the nearest cell phone tower. And I got a signal. I got it to work. However, the camera was a 5-megapixel high-resolution camera. And I had to lower the frame rate down to 1 frame per, like, 10 minutes to get this to work. But I got it to work. But they only got 1 picture, like, every 5 minutes. Eventually it did work. The other challenge was, you know, Verizon actually, once you hit a certain bandwidth limit, they started charging the customer. So they got their first bill, and they were real excited about it because it was in the thousands of dollars. But you get the idea. So there are some great ways to do this. So we could potentially buy a small 3G, 4G router, hook a camera to the back of it. The wireless broadband providers do actually allow you to set a static IP address now. So you can call Verizon, Sprint, or whoever they are, and you can ask for a static IP address. And yeah, we are, and so you can have the 3G or 4G router connect via a static IP address, and then you could have some computing device grab it. What I did it was with FTP because it was very, I could just send an image every now and then to some server and backed it up, and that worked out. The bottom line is if you're going to use cameras for mobile broadband scenarios, it's sketchy at best. You got to be very careful that you plan it correctly, and also you make sure that you get a provider that won't overcharge you for oversubscribing the circuit. All right, so that's a little bit on mobile broadband networks. I'd like to just take a pause and find out if there's any questions so far about what we're talking about. Does anybody have any questions for us? Please ask away. Don't want you to sit there with something on your mind and not have a chance to ask it.
I don't see any questions that came through in the chat pane, but go ahead and send them in there if you'd like to ask Guy a question.
All right, great. I have a, I forgot to ask a, hold on a minute. I have a couple of poll questions that I'll put out there for people to answer. See if we can get, see if people answer these 2 poll questions before I get moving there, so I'll let you answer that. All right, so we got some of our poll results back. It looks like we have a pretty good mixture of people out there. Most people on the call, about half of you have actually implemented a wireless camera before, and about half of you have actually used a bridge before. So for those of you who've had some wireless camera experience, feel free to give us a chat or ask us a question or maybe a statement. And then for the rest of you, I've got some more coming. So let's go ahead and dive in. All right, so we are now going to talk about when you might need expertise to help you with a mobile camera deployment or wireless deployment. So my rule of thumb when I was an integrator was, if I had a salesperson out there that was looking at a wireless deployment, I told them that if it was greater than 1,500 feet, then I wasn't going to let my guys engineer it. I had to call in expertise. I wasn't going to get stung. And by the way, I've been stung many times on wireless. So if I was trying to get to a camera location that was greater than 1,500 feet away, that's when I brought in the troops. I brought in at least a wireless engineer to take a look at it. And I'm not tooting my horn, but I'm pretty good at wireless. I mean, I get it. I've been doing it for years, so I understand what's there, but I'm just letting you know, I know enough about it to know that, hey, if I'm greater than 1,500 feet, stuff can go wrong, right? So I knew enough to bring in a wireless engineer to do a site survey, to take a look at the height and distance of where I'm trying to do the install, and to let me know the antenna type that I should use, what power of antenna should I use, and I would go from there, and then I would do my quote. Because I was just, too many times I had allowed salespeople to quote wireless implementations, and I would end up just getting stung because although my engineers thought, hey, we can do this, in reality they would always spec the wrong antenna, wrong cabling, wrong parts, and I would just get left holding the bag, and that just wasn't good. So I would say that 1,500 feet is probably a great rule of thumb. Under 1,500 feet, if you don't have a lot of experience, you may want to keep it down even lower, maybe just 100 feet until you get some good experience, and then you can go there. Another rule of thumb is if you're ever crossing other people's property. So if you're going from building A to building B, but building B has many different people's properties in the way, that you may want to consider bringing in an expert, at least for the first 3 or 4 times, until you get a little bit more experience. So, because there are some things that can go wrong with a wireless implementation, especially now that wireless protocols are getting more complex. Now that we're using multiple MIMO streams to connect wireless bridges together, it's getting a little complex with the antenna selection. So the longer the distance and the more obstructions you have, the more complicated the antenna selection gets. So because of that, I would recommend those 2 rules of thumb. Number 1, if it's greater than 1,500 feet, or if you're crossing property that is not yours or not the customer's. So what are those things that could go wrong, right? So let me just talk about what some of those things are. First off, in order to get wireless to work, you have to have it at a height that would actually work. So you have to have your wireless access point and its antenna, or your wireless bridge and its antennas, aimed at a height that can be received by either the camera or the bridge on the other end. Well, height always introduces issues, right? When you get something up on a pole or up on a tower, you start dealing with problems. One of those is lightning suppression. Another one of those is appropriate antenna selection. The further the distance gets, the greater chances you have of bouncing signal off the curvature of the earth, or bouncing signal off of the roofs of buildings, or off of trucks or cars or asphalt. And you get into some pretty technical issues between 2 bridges that could cause you lots of pain. One case, I had a police department I did an install at, where I had actually installed a small device like the one you're going to see here, and it was working beautifully. but every 45 minutes on the clock, it would drop for a minute and then come back up. I was like, what the heck is going on? Well, what I didn't know is the Marine Corps was doing they had I don't know what exactly they were doing, but I talked to somebody and figured it out. They had a microwave scanner that would scan the entire territory in like a clockwise fashion. And basically every 45 minutes it would hit right, it was smack aimed right at my antenna, and it would take my connection down. And then a minute later it'd be back up. And I would have never have known that had I not had to go hire somebody to figure it out. So these are some of the issues that you might want to consider. Also, sometimes customers do want to go long haul, and if they do, you may want to consider not using the public wireless spectrum, but using licensed microwave. And if you don't have the experience, I would recommend bringing expertise for licensed microwave. Some customers may qualify for the public safety spectrum, the 4.9 gig range. If they do qualify for public safety spectrum, you need to bring in expertise. So those are just some of the reasons why you may want to bring in expertise to help you with a wireless install. Most of us will do wireless cameras in small scenarios. We're just connecting across the yard or to another local building, or just down the hallway, or in our warehouse, maybe where we don't want to run cable. That's where most of us will deal with wireless, and we don't have these issues. But I wanted to make sure you understood where that dividing line was so that you don't get stung. All right. All right, let's talk about the evolution of wireless standards. And feel free to ask any questions, or some of you may not have much experience with this at all. Some of you may. So please feel free to ask questions if you have any. Okay, so wireless has gone through an evolution over the years, and there have been significant changes. And we'll go to the last one first. The one that is currently in draft is 802.11 AC. It was drafted in December of 2012. It's nearing the end of its draft cycle, so it will be an official standard. We don't anticipate any changes at all. It'll probably be the way it is. 802.11 AC uses the 2.4 gigahertz and the 5.5 gigahertz frequency bands. It can go from 450 megabits to 1.3 gigabits per second, which is pretty fast for wireless. It will work with any 802.11 A, B, G, or N device. However, those devices won't communicate at those speeds, obviously, but it does have the ability. It does now introduce this idea of using the 60 gigahertz frequency, and so it starts to do that. And, oh, I'm sorry, scratch that. The new standard they're working on is 802.11 AD. You might have heard of this. They've been advertising it recently, called WiGig. It's the idea that wireless will surpass unshielded twisted pair copper cabling in speeds. That's really kind of disingenuous because, remember, unshielded twisted pair cabling is baseband communication. It's full dedicated bandwidth. In order to get the kind of speeds they're talking about with WiGig, you would have to have the full spectrum and all MIMO streams being used. But they accomplish this by allowing for multiple streams at once, up to 8, and they also take advantage of the 60 gigahertz frequency. This could theoretically get up to 7 gigabits per second. So we're seeing new enhancements in wireless. Now, copper obviously can get up to 10 gigs right now if we have 10 gig switches and 10 gig cards. So it's not quite where copper is, but it's getting pretty close. So you won't see a lot of 802.11 AC out there. You have some manufacturers that are starting to produce products or have been producing products with the 802.11 AC. If you see anybody that has the WiGig on there, steer clear, because that has not been through the standards process as aggressively as the 802.11 AC. So if they say WiGig label, I don't know if you're actually going to get what they say. And of course, they'll never tell you the low range of the bandwidth. They'll always tell you the high, right? So on the box, it'll say capable of 7 gigs. But in reality, it's not going to achieve that. And that's the important point to know about wireless. You're never going to achieve all the bandwidth that you say you're going to achieve. Now, and the reason is because you have obstructions, because you have distance issues, because you have propagation delay, and because you have competition for channel and for space. So you're never going to get to the speeds that are always theoretical. Now, 802.11n and greater, so 802.11n and AC and AD have introduced this concept of spreading across multiple frequency bands, 2.4 and 5 gigahertz. And also they've introduced the idea of allowing multiple foot streams, MIMO streams. So you'll notice this, and in fact, so you understand it, the next time you go to look at a wireless device off the shelf, you'll notice that they're starting to come with multiple antennas, sometimes 2 or 3, or sometimes you'll see 4 antennas. The reason is because these products are capable of handling multiple streams. Now, I'm not going to get into the math of how that works, but the idea is that your devices can communicate with multiple streams back to this access point or to the bridge. And what's even better about it is it actually likes there to be some obstruction. So 802.11n and later, because they're using the multiplexing method they're using and the capacity of using multiple MIMO streams gives it the ability for the more obstructions there are, the better it is, because then all the signals don't arrive at the access point at the same time. They arrive kind of in a staggered approach, which allows the device to actually process this wireless transmission in a much more efficient fashion. So these devices are actually designed to work very effectively where you have stucco walls or drywall walls or wood walls in between you and your client devices. So you're seeing that 802.11n and later, you're seeing a lot better interior communication than we did before. A lot of you will still be dealing with devices that are in the A, B, and G range. Now, the B range is the 2.4 gigahertz frequency. And it basically went up to 11 megabits per second. Then we had 802.11g, which is the same thing, just a lot faster speeds, up to 54 megabits per second. B and G both have challenges with channel overlap. In a second, you'll see a slide where I show you that. With channel overlap, you have to really worry about other people on the same channel as you are. So you have to make sure that you correctly identify channel. 802.11a is in the 5 gigahertz frequency and does not you don't have to worry about channel overlap. Also, 802.11a 5 gigahertz is not used very often. Typically, when we use bridges, like the bridges you see behind me in a minute, those bridges will always be on the 5 gigahertz frequency because there's less chance of overlap and competition. All right, I have a question from somebody from the audience. So a question from one of the audience members was about setting up wireless between access points. You'll get these wireless bridges. In fact, let me flip to a different camera angle here so you can see it. So behind me, you'll notice behind me you'll see 2 white boxes kind of standing up vertically. These right here. So those are what the question is about. These are products that you can install on a building, and you can have them quite a distance apart. The question was, probably about 300 feet or 400 feet or so. These would be no problem to do that with. And so these would be capable of producing some pretty fast speeds between there. Some of them can brag as much as 300 megabits per second and greater. So the question from one of the audience members, would that be enough power to handle something like an IP camera or an IP VPN phone? Well, the bandwidth has nothing to do with your ability to run that camera or the phone, and that's the critical point here. Keep in mind that just because you can get a signal with a bandwidth limit doesn't mean that the camera or the phone is actually going to work. And the reason for that is the biggest thing is propagation delay. So when you put that phone on there, it cannot handle a delay because it's a real-time streaming protocol. So you're going to be doing a VPN to have that little phone connect, and it's going to have to VPN in, and then the phone is going to have to send its signal over this wireless. There can be very little delay. So the question doesn't become a matter of bandwidth. The question becomes a matter of how much delay do I get when I send that real-time streaming protocol. The cameras and phones are identical in the way that they handle that type of communication. So your testing needs to be on the validity and the power of the antennas. You got to make sure that the antennas are high enough gain and are connected with enough signal strength so that you get as very little delay as possible when sending that stream across the wire. You need to worry about that first before you worry about bandwidth. So the other issue is a lot of these higher end things like 802.11n are designed for lots and lots of devices communicating all at the same time to the access point, right? That's what they're designed to do. I got 500 laptops and cell phones and iPods out there, and they're all wanting to talk to and communicate with my access point. So they're designed to handle all these incoming data and just deal with it. Well, they're not designed for this constant streaming connection coming from a camera or a phone. So instead of using 802.11n, where it's constantly shifting spectrum, you may want to go with just 802.11a, and you may find it's a lot cleaner, easier to install, and more importantly, you don't get any propagation delay. So you just have to experiment with using different wireless methodologies to connect. But you know, you got to really make sure these devices are connected up well. That's absolutely important. Hopefully that answers the question. There you go. All right, so what are the technical differences in wireless standards? So what are the real technical discussion points here, right? Well, first off, every wireless protocol, 802.11 protocol, uses some frequency, right? And they will either use one channel or multiple channels together. But every one of them uses different frequencies. As I've told you, 802.11b and G use the 2.4 gigahertz. 802.11a uses the 5 gigahertz range. And then 802.11n uses both. And then AC and AD also use both. So it depends on what frequency they use. That is a big difference between protocols. The next thing is bandwidth and data rate. Bandwidth is usually the capability, if we used all the frequencies together, what would be the total bandwidth possible? So if I were to combine that now, obviously 2.4 gigahertz is a lot narrower of a band, so consequently, you know, the ability to have a larger bandwidth may be limited. That's not necessarily the case, but that's the idea. What really impacts you, more importantly, is the data rate. So you will see advertisements for bandwidth all the time. That really means nothing. That's just the overall capacity of the wireless signal. What we'll really want to focus on is the data rate. The data rate is achieved through modulation, through distance and range, through frequency, and through the number of MIMO streams. So this is how the data stream gets achieved. It wasn't until 802.11n that we started using MIMO streams. Now with AC, we could get up to 4, and with AD, we can get all the way up to 8 MIMO streams. And this is how we're getting up to the very large amounts of bandwidth that wireless can support. Also, most of the wireless protocols, starting with 802.11n, use this modulation method called OFDM. OFDM is the modulation method that actually allows your machine to communicate your wireless communication in parallel rather than in serial. So you can send out your communication out 4 antennas all at the same time, and the OFMDM modulation method figures it out on the other end and is able to reassemble it back into a serial stream. So consequently, 802.11n and greater, using this MIMO methodology, multiple antennas is important. Now be very careful on an outside installations. MIMO only works if you actually have multiple antennas. I've seen countless wireless installs where people will put in external antennas trying to boost their power with a MIMO device, and they only have one antenna, right? It just doesn't work. You got to have multiple antennas. You can buy these antennas now that actually have multiple antennas built in them in different polarities. You have a horizontal, a vertical, a 45-degree polarity. So you can have all these antennas that have multiple outputs. And so make sure that there's compatibility between the antenna that you're using and the MIMO output required by your 802.11 protocol. That's absolutely important. And then finally, range. OFDM has a greater range because it can handle a lot of obstructions. You'll notice that the narrower the band, the less range it can achieve. So 802.11b, very bad range, right? Because it's a very narrow band. Whereas 802.11a, you can kind of stretch it a bit. It gets a larger band. And that because you can go a little further. So 802.11a is what we use for bridging all the time. All right, I told you we would be getting technical there a little bit. Does anybody have any questions for me? All right, so we're going to jump into just a primer on wireless security. And after I'm done with this, I will take you through some step-by-steps on some products I have here. So let's go ahead and just jump into wireless security. Every time you configure a wireless access point, wireless bridge, or wireless camera, you have to determine what is the security methodology that you're going to use. So first off, there are some simple things you can do. The first simple thing is you cannot broadcast the SSID. Every wireless device will send out a poll of an SSID token, and your devices can sense that token, see the SSID, and decide to connect to it. Well, you can decide to turn that off, which means that when you set up the camera, you would have to know what the SSID is. You cannot rely on the broadcasted SSID. This is good because then you can't have some little hacker out there in the parking lot scanning your SSIDs trying to hack in, right? So even though anybody worth their salt could get past it anyway, it certainly reduces your chance of having some little hacker out in the parking lot trying to get into you. Secondly, you can filter on MAC. This is also, you can also get past this, but we could say, you know what, the only devices that are allowed to communicate on this wireless are these cameras with this MAC address. So that's the other way to do it. It's another great little simple way to secure your wireless network. You can also obscure the wireless. I would recommend to never have DHCP on my wireless network dedicated for security. I would turn off DHCP and I would force myself to manually set IPs on all my devices. This way, even if somebody does get into your wireless network, now they got to figure out what IP they're going to use, right? So they got to get on that and get the right IP, and they got to figure that out. So you're just making it harder and harder and harder for somebody to hack into the system. So I would recommend doing that. Also, if you know how to implement VLANs or you have a VLAN-capable switch, I recommend isolating the SSID being broadcast by one of these access points on a separate VLAN. The ingenious products that I'm going to show you have the ability to isolate an SSID on a VLAN. So you could have your SSID for the employees, for the data network. That could be one SSID. Maybe we call it Wi-Fi. And then our other SSID, which is the secure SSID that we don't broadcast, that one has been isolated to go to a specific VLAN where only security is allowed. And so I would highly recommend that if you can as well. When we get a chance, I'll show you that setting in the ingenious device here in a minute. Okay, all of these devices allow you to use WEP. But WEP has been deprecated as of, get this, 2004, right? So in 2004, the IEEE said, you know what, WEP is gone, right? Well, unfortunately, people still use it all the time. Actually, the payment card industry now no longer allows you to use WEP. I'm not sure what the penalty is if you're caught using it, but the PCI compliance requirements no longer even allow the use of WEP under any circumstances. So don't use WEP. Also, don't use WPA version 1. WPA version 1 was temporary. The IEEE had this new standard they were developing called 802.11i. And during that process, they needed something that could solve for WEP because WEP was just completely insecure. So they came up with WPA. WPA does not have all the extensions that WPA2 has. So you want to use WPA2. When you're in the routing device and you choose a drop-down, use WPA2 PSK. The PSK stands for pre-shared key, and that's what most of us use is WPA2 PSK. You can also choose encryption forms, and I've listed these in order of their protection ability. So on the lower end of the spectrum is AES, which is kind of government authorized encryption, and then you got TKIP, and then you got EAP versions. Most of the time when I'm doing wireless, I use WPA2 PSK with TKIP. That's normally what I use. You can use EAP versions, but you just have to understand the differences between the EAP versions, and also most cameras out there won't support it. Most camera manufacturers, you'll be lucky if they support WPA version 2, and you'll be even more lucky if they support WPA version 2 with TKIP. So the cameras you're seeing here, the TrendNet cameras do support WPA2. Some enterprise environments will want you to use 802.1x. Not all cameras will support that, and not all wireless devices will support it. 802.1x is very common in enterprise environments. Okay, there you go. Any questions about security? All right, well, we are going to take a deep dive into some technology now, because that's what I like to do. And I'm going to give you a look at the behind-the-scenes look at this lab behind me. There you go. You can see that now, hopefully. And you can also now look at my monitor, and you should see a couple of devices. Now, what I'm going to do is I'm going to stand up, and I'm going to explain the products behind me. And I'll explain how they're connected up together, because my goal is after I'm done with this, you could duplicate this in an environment for yourself. Now, what I'm showing you works perfect for a small office, small home office, or a small office scenario. Would work perfect for that scenario. So I'm using products that are designed for that purpose. However, the ingenious products you see here also could be used in a larger environment as well. So I'm going to get up and I'm going to show you these first, and then we'll come back and we'll take a look at the actual interfaces on the technology. All right, so here we are. Hopefully you can see the products here before you. First, I want to show you these two right here. These are the ingenious ENH500 products. And just like I told you, these are configured to work with the 802.11a spectrum. And you know the reasons why. They also work with 802.11n, by the way. But the 802.11a spectrum is common when using bridging. And so these devices are designed to be bridged. As you can see, on the back, I don't know if you can see that. I think you can. On the back here, by the way, it's got a nice little link quality thing here. And I'm actually connected right to each other, and the link quality is good. Now, I hope the link quality is good because they're 2 feet from each other. But you'll also notice that on the back here, it's kind of shaped like a pole. And the reason why it's shaped like a pole is because we typically will take these and mount them to a pole interface and then use zip ties, preferably the zip ties that will not erode with direct sunlight, and we'll zip them to a pole, and then we can zip these two and aim them at each other. And by the way, the propagation on these is outward, so they shoot outward. So you definitely want to have them aimed at each other. And the ingenious products actually give you a quick little guide on the back to let you know if you're aimed at each other well. And also in the software, you can see if the link quality is good. Basically what happens is these connect into a little device that looks like this, and this device gives me, it powers the bridge. So I have to provide a DC power source, which I have right here, a DC power source connected in. You can use the provided AC to DC power adapter, or you can use another DC power source to power this device. You basically plug the access point of the bridge in on one side, and you plug your network on the other side. In this case, I'll show you what I've done. I have this ingenious product over here connected to my network, and I have this ingenious product here doing its own thing, and I've connected to the back of it a TrendNet IP30 camera, which is a simple small camera with built-in infrared, this allows me, I could mount this to a wall or to an exterior location or something like that, or up under an awning. And so I have this camera connected right to the back of the ingenious product. And so I'm going to show you how that works. So let's go ahead and do that now. Let me show you how these products work. So I'm going to walk back over to my monitor, and let's go ahead and take a minute and look at these products. So as you can see here, I have two bridges, the one on the left and the one on the right. The one on the left, I've given the IP address 1.251, and the one on the right, I've given IP address 1.252. Now, don't confuse yourself and think these devices are routers. They are not routers. They are bridges, meaning they work at layer 2. So they are communicating layer 2 traffic between each other. They are not routing IP protocol. That's why these guys are on the same network. They're on the same network. Consider it like a great big switch in the sky, right? You've all plugged in cables into the back of switches. We've all done it. So over here behind me, you have two bridges, basically, and they are acting as if they were just a switch. So if I plug them into them, it's like I'm connecting into a switch, basically. So what I want to point out here is one of these is in access point mode, and one of them is in client bridge mode. And this is very important. The one that is connected to my network is the one that I put in access point mode. So the one that I've connected into my network switch is the one that I program in access point mode. Now, how do you do that? Well, you go to operation mode down here under system, and you can choose a radio button here, access point, client bridge, access point or client bridge, right? So we definitely, and by the way, you could make them a client router, but I don't want to talk about that right now. I'm talking about bridging to wireless cameras. So I've made this one an access point. So it's going to serve as an access point, which means I could have PCs, or I could have laptops, or I could have cameras or bridges connect to it and get connected. Once I've set it that way, then I would go to the other device and I would go to operation mode. And on this other device, I would set it up as client bridge. So looking back at the video here behind me, the one on your right is the one that is set up in access point mode, and the one on the left that has the camera connected to it is set up in client bridge mode. Once you're done with that, then what you do is on the access point side, you need to go down to wireless network. And in the wireless network settings, here's where you set the wireless mode. And right now I'm using AN mixed because I want to use all both the 20 and 40 megahertz frequencies. If you wanted to, you could narrow this down and just use A and narrow it down to just one of the frequency levels. And so there you go. If you have conflict or contention or problems, then you want to play around or experiment with that. And also notice here that I am using SSID in Genius 1, and I've enabled this, and I'm basically broadcasting those. Now I'm going to take a look at the advanced settings here under Edit. Okay, and under here I can put the SSID name. Here's where I can choose to suppress the SSID, where if I don't want the SSID to be broadcast, right? I don't want to broadcast SSID to do one of those security mechanisms that I told you about earlier. I can do that here. Also, remember I told you it's a good idea to isolate an SSID to a VLAN. if your customer has VLAN capable switches, you could put the VLAN ID in here and have that SSID automatically be routed to the VLAN. Of course, you would then have to take this wireless access point and trunk it to that switch. Now, it depends on what switching product you're using. Some switching products will auto-accept trunks and will automatically connect this access point as a trunk. Others won't. It just depends on the switch product. You can then set your security mode. And I want to show you here that this particular product supports WEP, bad, right? You know that's bad now. It supports WPA, also bad. We don't want to support that because that's the early pre-ratified standard. And here's WPA2 PSK, which is the one that we want. So if we were to choose that, we could then select what type of encryption method we wanted. We could use TKIP and AES, or we could just do TKIP or just AES. And those are your encryption methodologies. I always just do TKIP. You then need to provide a pre-shared key. And by the way, the group interval needs to be the same on both sides. Now, very important, the passphrase. Now, I am not going to teach you guys how to hack wireless networks in this particular class. However, it is possible to hack WPA to PSK. If you were to set a passphrase that was like an 8-character plain text word, then I could hack into it, no problem. So, very important, if you're using WPA to PSK, you must use a complicated passphrase. Do not fall into the trap of creating a passphrase that's a word like setup or test or this is the best, password. That's the first thing I'm going to try hacking into the system, right? So don't do that. Instead, create a complicated password. The IEEE recommends 5 words in succession with each other, if at all possible. Vince asked me, by the way, what model or part number this access point was. This is the ENH 500. I will show you that in just a second. I will show you that in a minute. Okay. So, and so there you go. That's how you set up your security settings. By the way, before we move on, over here to the left, you remember I told you another easy method of security is to set up a wireless MAC filter? Well, here you go. You can specify the MAC address of the wireless device, and you could only allow MACs that you know about to connect to this wireless network. You might as well use all the tools you have available, right? I mean, you don't want anybody else on your bridge because this is dedicated for security. So you can go ahead and simply type the MAC address in here. Now, how do you get the MAC address? Well, most cameras will have the ability for you to view the MAC address pretty easily. For example, this camera right here, I can go to the setup window, and usually you will find a MAC address in here. And notice right here, this particular TrendNet camera, the IP32 PI camera, notice that I see the MAC address right here. So what I would do is I would simply type in the MAC address that I wanted to limit. Also, you want to limit the MAC address of the other bridge, right? You don't want to block out the MAC address of the bridge you're trying to connect to. All right, so there you go. So here's the wireless network settings. I'm now broadcasting in Genius One. Over on the other side, so looking behind me, you'll notice on the other side, on your left there, is the access point that has been configured in client bridge mode. And notice here, I've got that set to client bridge mode. And basically, I'm going to go down here, and I'm going to click on wireless network now. Now, this one's different. I'm not actually creating an SSID. In this case, I'm just simply connecting to an SSID. So in this case, I chose the same wireless mode. That's very important. 802.11a mixed, right? And I've also now specified the SSID. If I was not broadcasting the SSID, I would have to actually type in the actual SSID to connect. I could, if I was broadcasting the SSID, click Site Survey, and this is one of the nice things about the Ingenious product. It'll automatically site survey all of my SSIDs available in my area. So it's going to go ahead and scan. This takes a few minutes for it to scan. But notice right here, just in my immediate area, I've got 1, 2, 3, 4, I've got 5 SSIDs broadcast. And notice some of these have no security. And most of them, luckily, are using WPA PS2 PSK. Notice right here, this one is using both WPA version 1 and WPA PSK. So there you go. That's how you can do it. And then, of course, you could connect to one of these and then connect. Now, notice this one is not seeing everything in the 2.4 gigahertz band. Why? Because this is only capable of 5 gigahertz. This particular bridge is only capable of 5 gigahertz, so I'm only doing a site survey of the 5 gigahertz range, either using 802.11a or end. All right, so that's basically how you connect to it. Once you connect to it, if you did require security mode, you could select the security mode and then provide the pre-shared key. So for example, I would go to PS2, WPA PSK, select the encryption mode, and type in the correct passphrase. All right, there you go. That's how you connect to these cameras. Now, looking behind me, I have this little TV IP, this little TrendNet camera back here. That little TrendNet camera is connected to this wireless bridge directly, and the wireless bridge is transmitting over to the other wireless bridge, which is connected to my network. I should now be able to talk to that camera by its IP address. So I've assigned it an IP address. In this case, I assigned it 192.168.1.100, and now I'm going to the live view of that camera. And this is a pretty neat little camera, and as you can see, I'm able to see that camera, and just to prove it to you, I'm standing over here by the table, and I'm going to put my hand in front of the camera. Woohoo, there's my finger, see? And so here's my lab, and this camera is connected to the back of this ingenious product, and basically that's how you configure a camera to connect through a wireless bridge product. So these, the theoretical limit on these wireless bridges, by the way, is 30 kilometers. I don't think in any practical scenario you would actually reach 30 kilometers unless we were out in Phoenix somewhere and there was absolutely no other wireless signal. We might get it there, and we certainly wouldn't get it at full bandwidth, but they can still extend a very long distance. So these are definitely a great product. And so if I ever needed to place one of these products at a remote location, this is an example of how you would accomplish that. Let's go ahead and now move into the second scenario. The second scenario is to use, oh, and by the way, to answer the question from before, this is the ingenious ENH500 product. And in order to accomplish this, you would need 2 of them. So let's go ahead and take a look at what else is on my table. So I have over here an ingenious ENS202 exterior wireless access point. This product, like all other ingenious products, can be configured in both a bridge or an access point mode. In this case, I'm using it as an access point mode. On the back of it, you will notice that it also has a signal strength meter, just like before, and it simply just connects into your network, and you can use power over Ethernet to power the device. And I am, in that case, using power over Ethernet to power this device. This thing is capable of a variety of different wireless spectrums. I will talk about that in a minute. Notice that it comes with 2 antennas. By the way, you could, if you wanted to, attach separate antennas instead of the antennas that come with the device. So remember, in some scenarios, you may require a higher gain antenna, or you may require antennas that have a different direction. These are more omnidirectional, so they the spreads pattern is universal. If you wanted something more directed, you might use a different antenna type, and you're certainly able to do that with the ingenious product. I have provided also here, thanks to TrendNet. TrendNet has provided me with a very simple little wireless IP camera. This is their TV IP672 Wi-Fi camera. I'm going to turn it around for you. You will notice that I have a wireless transceiver here, and I also have a UTP cable. I initially programmed this using the copper cabling, And then after that was over, once you get it working with the copper cabling and everything's fine, you've rebooted the device, you can then unplug it, and then the wireless will start to work. In this particular case, I'm powering this with a DC power source. And this particular camera is a pan-tilt zoom camera, and it has built-in infrared, meaning that it has some pretty superb nighttime viewing. The camera is a pretty nice camera for small or home environments. It's probably not the best camera for a large environment because it's just not, doesn't have the kind of deployment features you would expect in kind of the more ruggedized PTZ cameras in the market. But this is really good for a small office, especially for a customer that needs 1 or 2 cameras deployed in a particular situation because they want to monitor their children or their employees or stock or inventory or whatnot. It works out pretty good for that, and the wireless feature makes it possible. So many of you may wonder, how do I connect this camera up to an access point like this? So we're going to go ahead and look at my screen again, and we're going to go over that. All right, so looking back at my screen, I'm going to now connect to the Ingenious external access point. By the way, Ingenious produces interior access points and exterior access points. This is a pretty good access point because you can mount it to a wall, and it's generally going to withstand weather conditions pretty well. So everything's sealed tight on it pretty good. The network cable points downward so it won't get rain and stuff in it. So that's the access point. Pretty nice little lightweight product to use up on a building or on a wall. All right, let's take a look at this. First off, let's go to operation mode. And notice that this is in access point mode, right? So that's the first thing we have to worry about, is this has to be an access point mode. Second, I'm going to go to wireless network. And I've decided to use B, G, and N mixed. So this is capable of the 2.4 gigahertz spectrum for B, G, and also N. And I've used it for mix for compatibility. The reason why I did that, I always start using it that way. By the way, whenever I'm setting up a camera, I always set it up with no MAC address filtering, broadcasting the SSID, and 802.11bgn mixed with no security. And I get it working. After I've gotten it working, then I go back and I make tweaks and add things one at a time until I have it fully functioning. So in this particular case, I've used Ingenious 3. I've set up no security, but notice that if I click Edit here, you have all the same settings that I talked about before. You can identify a VLAN ID, you can identify a security mode, all those things we talked about before, right? So this is broadcasting the SSID Ingenious 3. That's pretty much it. It's really easy to set up. I can also use wireless MAC filters, all that kind of stuff like we talked about before. Now, let's go ahead and take a look at the wireless internet camera. So this is the TrendNet IP672 Wi-Fi camera. You're now looking at it, and you can see me talking right over here in my chair. Hello. And over here, notice that I can pan, tilt, zoom the camera, and this camera is operating over that wireless network. And I will prove that to you in a minute. But I'm now pan, tilt, zooming this little camera, and I'm taking a look at everything on my table. See that? Pretty good. There's the TrendNet little camera I showed you. There's the Ingenious products. And there's the boxes that the products came in. This camera also allows you to do presets. So for example, I wanted to go back to that storage door. I could have it automatically go to the storage door. I could have it flip back around and aim in a different direction, back towards my front door. And I could even, I don't know what that's going to do. I forget what that was. Oh, this is going to go look at the TrendNet products on my shelf. There you go. So I could have pan, tilt, zoom presets, right? I can also have it automatically record, blah, blah, blah. So click on the setup option, and this is how you configure it wireless. By the way, in order to configure it wireless, you must first have it connected to the wired network, and then you must configure the IP address, all that. And while it's connected to the wired network, you go to the Network tab, and notice I've configured my static IP address. You're going to go to the wireless setup. And here is where you're going to scan for your SSID list. And here I'm going to see all my SSID lists. Notice I'm seeing different SSIDs because this is scanning the...
Hey, Guy,
Yeah.
I'm so sorry to interrupt. You know, the view is on the product table. We can't see any of the configuration stuff you're talking about.
Oh, really? Oh, all right.
Yeah.
Oh, it's not sharing my monitor anymore?
No, it's not sharing your monitor.
Oh, all right. That's a bummer. All right.
Oh,
Well,
no, I see your monitor. I see your monitor, and I see the view. Sorry about that.
okay. All right.
Yeah.
Cool. All right. So I wasn't speaking in vain. All right. Good. I hate doing that. All right. So we are looking now at the SSID list. Now, this is seeing things in the 2.4 gigahertz range, not the 5 gigahertz range, right? So you're seeing all the people near me using 2.4 gigahertz. So I'm then going to obviously select Ingenious 3, which is the one I did. And by the way, you never need to use ad hoc mode. It's always infrastructure mode. And here's where you would set your security. Now notice the camera here supports WPA PSK, and you can choose AES or TKIP. You have to pick one or the other. It doesn't let you do both. So notice how camera devices and the access points that serve them may have different types of settings, so you have to be careful on what you choose. And then you would type in your key. I'm going to click cancel on that. Once you've got the wireless working, you reboot the device, and then you can go back into it and should be able to hit it by its IP. So basically, that's how you connect a wireless camera up to an access point and get it up on the network. And by the way, I've been messing around with this while I've been waiting to teach this class. And I've been testing the throughput on this little Ingenious access point to see if it could handle all of the different things. Now, I put up other cameras besides the TrendNet camera as well. And I was able to do 30 frames per second, motion JPEG at I did put a 5 megapixel camera, motion JPEG at full frame rate at like 15 frames per second. And the access point handled it with no problems. Now, I haven't tried it with like 10 of them, but maybe I will one of these days, and we'll see if it handles it. But one camera seemed to work out great. Of course, I'm right here in the lab. Maybe if I did one, several offices down, we would see a different story. But you definitely want to experiment and practice with this before you try to deploy this with a customer. Okay, next scenario. So I'm going to go back to my table, and we're going to talk about the next scenario I've set up. Now, I've saved the easiest for last. I'm going to move that camera away from my stomach. There we go. All right, so I'm going to move I've saved the easiest for last. Many people ask the question, if I've got a camera set up, maybe at a warehouse, or maybe at somebody's home office, or maybe at somebody's house, or at their business, companies oftentimes want to connect to these cameras over the internet. So how do you connect to an IP camera over the internet? Well, it's actually rather easy. If you use a device, such as a routing device or a firewall device, it creates this ability. So right before you, I have here in front of you the TrendNet 4-port VPN router. They have very long part numbers. I'll read it to you slowly. It's their TW100-BRV214. Basically, this device is about the simplest 4-port VPN router you're going to find on the market. On the back here, you have 5 network ports. One port is reserved for the internet side, or the one side of the network, and the other 4 ports are reserved for the internal side of the network. So that's basically how the device is physically connected. In this case, I have configured this camera right here to be connected to the back of this TrendNet device. And I've plugged the TrendNet device into my network here in the lab. So I'm going to show you now how to connect this TrendNet guy and have it route to this camera and talk to you about the issues there that come up with that. So let's go ahead and take a look at my screen, and we'll talk about how that works. All right. First, I'm going to remove the pan-tilt zoom camera from watching my back, because that's really unnerving. There we go. All right, so now let's go ahead and take a look at the router settings. So we're looking at the 4-port VPN router from TrendNet. And most routing devices, not just TrendNet, they're all about the same. They all basically provide the same functionality. This is about the simplest little box you're going to find when it comes to setting up VPN routing stuff. So it's a pretty nice little box. First off, you're going to go to Network Settings. And I'm going to have to type in the password first because it's been sitting idle for a while. The default password on these is admin, by the way. Whenever you start up the TrendNet box, it always wants to know if you want to use the wizard. I promptly say no wizards for me. And then I go inside the device. Now, we're going to click on Network Settings. And I want to point out that the LAN IP address is basically the 4 ports that are on the interior of the network. So they're on what we call the inside. The outside address is an address that I've assigned on my network. And notice that I am connecting to this TrendNet router via the outside IP. So this would be the IP that would be on your DSL side or your internet provider side. So normally you would do this with a static IP address. However, this also supports dynamic DNS. So if you had an automatically changing IP address, you could use dynamic DNS if you wanted to. But this particular case, I've used a static IP. I've assigned it. And I've provided all my IP address information there. Now, in my case, I have multiple IP addresses that I can assign to this interface. Because of that, if you can assign multiple IP addresses, it makes a lot more sense. So I have a connection here from Verizon, a Fios connection. So I could connect this, and they provided me with 8 IPs for my connection. So I've got multiple IPs I could use. If you get the scenario we've got multiple IPs, that's good. Because I'll show you what you can do. You can go to virtual computers, and you can specify another global IP. So in this case, 240 I'm using to manage the device, and 241 is another global IP address that I've assigned that I'm going to use solely for the camera. So 192.168.1.241 is the IP address I'm going to use on the outside, and the IP that I've assigned to the actual camera device is 192.168.10.200. So basically, I am mapping the outside IP to the internal local IP. Once you're done, you can just go ahead and click Save. You can save your changes. Okay. After you're done with that, you then go to forwarding rules. And in this particular software, they call it a virtual server. So I'm going to click on virtual server. And what you do is in the server IP, you're going to put the global outside IP in the server IP field. In this case, because I created a virtual server IP, I'm going to use that IP. I'm then going to specify the port that people would come into to see my camera on, and I'm going to specify the outside port they would see to get to the camera on. Now, cameras can have different streams on different feeds, and I'll talk about that in a minute. You have real-time streaming protocol, motion JPEG, MPEG, and you have TCP over port 80. You can connect to these cameras in a variety of ways, and we'll talk about them in a minute. Because this is going to be a TCP stream over port 80, I'm just going to use TCP, and I've enabled it. That's it. That's all that's required. Now, some of you may be asking, well, what happens if I only have one IP? Well, if you only have one IP, then you would put the IP address of your VPN router, in this case 240, and I could not use port 80. I would have to come up with a different port to connect to because by default, your TrendNet box is going to use port 80 for management, and you can't use that port 80 for something else. I learned from hard experience just messing around with this. I tried to use port 80 twice, and the device wouldn't give me management access again, so I had to reboot it, use the reset button. By the way, the TrendNet product has a reset button right on the front. You hold it down for 20 seconds, and it resets it back to defaults, and then I went back in and tried it on a different port number. Anyway, that's how you connect to it. Now that I've done it, I should be able to connect to 192.168.1.241 and see that little dome camera behind me. So I'm going to go ahead and do that. Here we go. I've now connected to that little dome camera, and you can see me right here. So that camera is on my table, and you're looking at me from behind, and that is the dome camera being communicated through that VPN router device. So this would be as if the camera was on the internet. Now, a couple of things I want to point out about camera devices. I'm going to go to the configuration section, and then I'm going to go to video, or network, and on this particular one, I'm going to click on streaming protocols. Here is where I can set my ports. So if I needed to come up with a custom port other than 80, then I could do so. By the way, if you use custom ports, you do not want to use ports within the defined range of ports. So I would recommend, sticking to something 10,000 or 5,000 above is typically the standard. But you can go, I would usually use a port 5,000 above for assigning a port, a custom port. You can also notice that there are a variety of streams you can use here. All of these streams can be accessed by typing http:// the IP / the name of the stream. And that's how you can connect to the motion JPEG streams coming out of this camera. You can also get real-time streaming protocol. If I wanted real-time streaming protocol to work, then I would have to enable port 554 on my device. So I would have to go here, and I would have to put 554 here and put in my IP. Right? And I'm going to go ahead and just use TCP in this case, and I'm going to enable that. So I've now allowed port 554. That is the real-time streaming protocol port. Now, what I can do then is I can use a program like VLC to test it with. So you can use VLC or a program like that, VLC Media Player. It's a free download. I won't walk you through that because we're going to run out of time. But you can use VLC Media Player, and you can connect to that real-time streaming protocol. You can also publish real-time streaming protocol with programming languages like Java and embed that on a website. So you could potentially, if a customer wanted a particular camera to be visible from the internet or from a web page, you could use the real-time streaming protocol to post that camera out on the web if you wanted to. So, but in order to do that, you would have to allow those ports through your VPN or through your firewall routing device. All right, that's it for connecting a camera up to a small routing device and allowing it through to connect to the internet. I've completed my 3 demonstrations. My next thing is I'm going to show you how to connect to Physical Security University to gain access to this material and see that. So before I do that, though, I want to entertain any questions. So does anybody have any questions for me before I show you the Physical Security U interface and how to access this particular course?
I don't see anything in the chat window.
I don't either. I've either put everybody to sleep or they're mesmerized with my brilliance. I don't know which it is. Hopefully it's the latter. All right, so now what I'm going to do is I'm going to show you Physical Security University. So what I'm going to do is open up a web browser here. So, and I'm going to go ahead and log out of this interface so you can see what it looks like when you see it. So you're going to go to physicalsecurityU.com, and physicalsecurityU.com is where I host all of this content. Now, if you do not have a physicalsecurityU.com account, you need to register. Over to the right-hand side, you can click the register button, and it will take you to a page. I'll show you what that looks like. And we're not asking you for a lot of details. The only thing we're asking you need to be is an Ingram Micro customer, right? Because this is free to Ingram Micro customers. It's not free to anybody else. So if you are an Ingram Micro customer, which you have to be, you'll put your branch number in here, your Ingram Micro number, and just some basic contact information. So put that in there, click Submit. Within a short period of time, we will register for and give you an account, and then you will have access to Physical Security U. Once you have an account, if you want to participate in one of the courses, you need to enroll in that course. So to enroll in the course, click on Enroll here up at the top, and you can see all of the courses that I'm offering. You might want to bookmark this page all of the courses that we offer will show up in here, and all of them will have an enroll option over to the right. So if you wanted to enroll in the PSU-301 course, if you're not already enrolled, then you would click Enroll for PSU-301, and you would basically type your name, whatever, and your company name, your Ingram Micro customer number, and that will enroll you in the course. A lot of you have already done that, so that was a repeat. I'm sorry, but most of you have already done that. So now that you understand how to enroll, register, and then enroll, once you've done so, you can then access the PSU-301 course. So now I'm going to log on. And once you're enrolled in the 301 course, you can then click on it. Now, this is the way this course is organized. First off, there's an online course module. So the way these run is you click on the module, and then you click enter. That will enter you into the course. And what this is going to be is what we call a SCORM module, and you're going to hear music in a second here. Welcome. There we go. So this is how you connect, and I'm going to turn the music off, but this is how you connect to the online course module, and you can navigate this course with the forward and backward buttons. And there's a lot more detail than what I discussed today in here. So if you want to see the slides and you want to review the content that I discussed today, all of the content is in here, and I've pre-recorded my lecture and my discussion into these modules. You can navigate through them, and you can see all the stuff that we talked about today. So that is the online course module that you can see in the 301 course. Next are demonstrations. If you want to see the demonstrations that I did today, I've pre-recorded video demonstrations of exactly what I did in the lab today. And there's a few more too. I haven't posted them yet. There'll be another one up here as well. But you click on it, and it's basically a YouTube video that you can watch that basically goes over the products. And so if you click play there, you can watch the video. I go through the setup, the installation. So if you didn't catch everything we did today, you can go back over it again on the video there. So if you go back to the 301 header here, after this webinar is done, after this training session is done today, I will post the recording of this to this archived live session. So if you want to watch this in session over again, then you can do so. It will show up in here just as soon as I'm done transcoding the video from today's recorded session. So that's what will show up in there today. All right, let me just point out a couple of more features of the physicalsecurityU.com website before I conclude this session. Over to the right, when you first go to the home page, over to the right, you have upcoming events. All the training courses that we're launching will be usually announced up to 2 weeks in advance, and you will see them posted up here in the upcoming events section. Also, if you're interested in it, we are creating blogs once a week, and the blogs are showing up over here. If you would like to read one of the blogs, you can click on it, and it'll open up one of the blogs that we produced. And so physicalsecurityU.com and the blogs are now linked. So you can see the blogs over here to the right. Please feel free to watch them, read them, learn from them. I'm trying to mix it up on what I talk about, so you're welcome to look at that. Finally, if you want to get up-to-the-minute announcements of everything that I'm doing at physicalsecurityU.com, you can follow me on Twitter by clicking the follow button. And what happens is every time I post a YouTube video, every time I schedule a course, every time I add content to physicalsecurityU.com, I post it to Twitter first. And so if you want to be the first to know, then follow me on Twitter. If you want to catch all the videos that I'm doing, you can also click on the subscribe YouTube button, and you can go to my YouTube channel. Just real quick, I'll show you what that looks like. So here's the YouTube channel. We're probably going to get an advertisement. Oh, we got a Jeep advertisement today. You never know what you're going to get. So over here, if I click on me, here is the Physical Security U channel. And all of the videos that I'm posting are showing up over here. And I'm trying to mix it up. Vendors or manufacturers from Ingram Micro are having us post different videos. And these are all done by me, 100%. So there's not a lot of marketing hype. It's just basically me diving into the product and showing you what it does. And so you can go through there. And lots of archived courses are up here as well. So you can take a look at everything that's coming out for me on YouTube. I'm producing about 3 to 4 videos a week now. So you can get quite a bit up there by going to my channel. I got a question from somebody asking for a contact, and no problem, we will do so. Okay, so that's the YouTube channel. That is physicalsecurity.com, and that's it. By the way, just to give you a little heads up, we have courses coming out on vertical solutions. We have courses coming out on solutions-based courses like we did today, more technical. And then I have some introduction and some fundamental courses coming out as well, so please stay tuned. By the way, I have a full tutorials on how to navigate this interface under the tutorials course. You can watch these videos to see how to use PSU. I also have a Physical Security University events course, and in that course you can view all the previous conferences that I may have done over the last year. So feel free to use this as a resource and learn as much as you can. And by all means, contact me, reach out to me whenever you need to regarding Physical Security University or things going on at Ingram. Any questions before I conclude this session? Any questions from anybody? Feel free to ask away. This is your chance. This is your moment. All right, well, I'll take that dead silence as an excuse to end this session. Please take advantage of what we have posted online. I've put a lot of effort into it, and we look forward to seeing you in the future of Physical Security University courses. Thank you very much.